half of chapter 4. Because we have completing the square, and we have the quadratic formula, and then we learn a little bit about imaginary numbers. And most people would think, hey, we don't know anything about imaginary numbers. That's got to be really tough, right? Well, it turns out imaginary numbers are not that difficult to do. So this is where everybody needs to pay attention. And if at any point today you're saying, I don't know where she got that, have me slow down and we'll get everybody where you need to be. So completing the square, if you look at this, you'd say, that doesn't look like completing the square, that looks like factoring. That's because completing the square uses factoring. And the good news was, you were really good at factoring, so that's going to help a lot. If we have x squared plus 8x plus 16, and we go through our list and we say, is there a greatest common factor? Is there something I can pull out of all of these? Nope, there's nothing there. And then the second thing on the list is going to be perfect squares. We'd notice, hey, wait a minute, this might be a perfect square trinomial, because this is x squared, and this is 4 squared, and I have to remember how to check that middle term, and I know it's been a week off. Does anybody remember how to check the middle term? What do you remember, Evan? That's exactly what you do. And x times 4 is 4x, and when we multiply that by 2, we get 8x. So that means we can write this as a binomial squared. And that's just going to be x plus 4, because that's what we squared to get x squared plus 8x plus 16. Everything was pluses, had to be a plus in there. Now, what we just did is what you want to do when you're completing the square. When you're completing the square, you want to find the number that goes in this last position that makes you able to make it a binomial square. And so that's why it's so important that we're able to factor this stuff, because then we can see, hey, I can get this to be something squared. So for B, again, we look at it and say, okay, is there something I could pull out of all of these? Nope. But might be one of those perfect square trinomials. Because we've got the x that's squared and the 3 that's squared. And if you multiply those together and multiply by 2, hey, 3 times x is 3x, times 2 is 6x. So far, so good. We get on to C. Can I take that 4 out? I mean, it's really obnoxious. I can take it out 20, but I can't take it out 25. It won't work nicely. But then I notice, well, this is 2x squared, and that's 5 squared. I wonder, maybe this one's a perfect square trinomial as well. So 2x times 5 is 10x. 10x times 2 is 20x. Hey, it is. So what should I put in those parentheses, everybody? What should go over there? 2x plus 5. So why do we want that? I mean, if that's like a big step when we're doing completing the square, why is that a step? You know, it just seems like it's a lot of work to get this squared business. Well, because if we have something like this, we don't have to write x plus 3 times x plus 3, multiply it, move the 16 over and factor it. That's a lot of steps. Instead, we can say, I'm going to get rid of that little 2 by just taking the square root of both sides. And hey, wait a minute. The square root of 16 is 4, but it could be a negative 4. And then all we'd have to do is subtract 3 from both sides. And we'd realize, wait a minute, I can do that math too. Negative 3 plus 4, that's a 1. And negative 3 minus 4, that's a negative 7. And you get the answers a lot easier than moving everything over to one side and factoring and doing all of that. Sometimes it wouldn't be factorable anyway. This one would have been. But that's the reason we do this process. We want this something squared so that eventually we can take the square root of both sides and have things work out nicely. So that's why we're doing this completing the square. Solving by finding square roots. Well, that's why I had to simplify square roots right before the break, because sometimes that's going to come in handy. I don't know why that little 2 is all goofy up there. I remember fixing that last week, but didn't stick. So I look at this and I think, hey, maybe I could subtract 46 from both sides and factor it. You could, but that would be kind of the hard way to do this problem. So instead, I notice, hey, there's no x to the first in this at all. There's no middle term. Then I don't have to factor. If there's no middle term, I can just solve. I can subtract 10 from both sides. Then I could divide by 4. And then how do you undo squaring? Square root. But again, if we physically write down the square root, then we have to do that plus or minus thing. The answer is positive 3 and negative 3. No factoring involved. You know, just solving. And most people really like the solving. You know, it's easier than trying to find combinations of numbers and working through them. All right, so now this one is 3x squared minus 5 equals 25. So what would you do for a first step? Add 5. Second step. Divide by 3. And then we get a little concerned because 10 is not a perfect square. Well, you know, we take the square root of both sides and we say, so x equals plus or minus the square root of 10. Simplify the square root of 10. It's not a perfect square. Then you check and see, are there any perfect squares that would divide into 10? 9's not going in there nice and neither is 4. It's a perfect answer. We're done. That's all we could do with it. You know, there was no simplifying that we could do after we took the square root of 10. But it is 2 perfect answers. Positive square root of 10 and negative square root of 10. Did your little powers get in the right spot on your packet? Oh, good. Because this is just messed up here. All right, so go ahead and do 8, and then I'll call on somebody to take me through the steps that they did. Okay. Take what's first step. All right, so it looks like lots of you are already buzzing through B. So let's talk about A here. Nathan, what'd you do for first step for this one? Added the 10? So we add 7x squared equals 35. Kimlin, what do you do next after that? Divide by 7. And then we have x squared equals 5. And Caitlin and Dave, what do you do after that? Square root that bugger. Anything you can do to simplify the square root of 5? Nah, but it's a perfect, it's 2 perfect answers there. Plus or minus, that 5 looks weird. Plus or minus the square root of 5. Perfect answer. Now we could, if the book said, you know, round your answer to the nearest hundredths or whatever, we could punch it in. But most of the time we want to leave these perfect. All right, so B is 2x squared plus 9 equals 13. First step there. Haley, what's first step on this one? Subtract the 9. We get 2x squared equals 4. Luke Kutzer, what'd you do after that? Divide by 2. So x squared equals 2. One more step to go. Trent, what do you do after that? square root little thing there, yeah. And then just always remember plus or minus, and you take one last look at what's under the radical. Square root of 2, there's nothing we can do with that. You know? It's done. Perfect answers right there. So this is the reason we like to do completing the squares. A lot of the time it feels like it's so much easier than factoring, you know? You don't have to find all of those combos of numbers. So now, how is this going to work when it doesn't look as easy as the last ones? Now, why do I say that? Because in the last problems, we didn't have an x term. There was x squared, but there was never just an x. Now we look at these and we see what is the solution of x squared plus 4x plus 4 equals 25. Now that looks a lot more complicated. But if we focus on the fact that this is something squared and this is something squared, then we can start to feel like, hey, wait a minute, this might not be as different as we think it is. Because if we check that middle term here, by multiplying x times 2 and doubling it, hey, we can write that as a binomial squared. So this becomes x plus 2 squared. And then we remember, well, when we had something squared before, we took the square root of both sides. So that would be what we would need to do here. We'd take the square root of both sides and say, well, x plus 2 is going to equal plus or minus 5. This is square root of 5 is 5. But there's 2 answers there. So to get to the 2 answers, we would subtract 2 from both sides. And say, well, it's either x plus 2 equals, oh, they didn't do that part first. I would do this. But you certainly could write x plus 2 equals 5, x plus 2 equals negative 5. Just kind of adds another step in there. So when we have that, we see, well, negative 2 plus 5, that's 3. Negative 2 minus 5, that's negative 7. There they are. We have our 2 answers. So, could we have shoved the 25 on the other side and factored this? Yes. Would it have been more difficult? Yes, it would have been. That's the whole reason we want to watch for these perfect square trinomials. And we want to factor those and see that, hey, this is a little easier by finding the square roots. So this one says, how about x squared minus 14x plus 49 equals 25? The first thing I want you to do is I want you to check this for me and see if it is a perfect square trinomial. So do the math on it and see if it works. Is it a perfect square trinomial? Faith, question? Yeah. Oh. For this one, here, we get the negative 7. And here, we get the 3. So, Faith, this is the one where I said I would just go right away to negative 2 plus or minus 5. And just do negative 2 plus 5 is 3. And negative 2 minus 5 is negative 7. But you can, whatever way you want to do it, as long as you can get there, that's what I care about. So 7 times x is 7x, and when you double it, you do get 14. So what should we put in the parentheses here? If this worked, what goes here? X minus 7. And that's because this had subtraction in between the first and second term. All right. So now we have that. What would be the next step? Square root both sides. like theirs says, it says definitely you could write it as two equations at this point, so you could come down here and say, all right, x minus 7 equals negative 5, x minus 7 equals positive 5. Or you go up here and say, well, I'm going to add 7, both sides. And then just do the addition and the subtraction. Either way, you're going to get the exact same answers. Like I said, whatever works for you, that's what you want to do. All right. So this just seems too perfect world. I mean, are they going to come to us prepackaged like this where they're already perfect squares? The answer is, pardon me, for today's homework, yes. They're going to come all nice and prepackaged and everything will end up looking beautiful. But as we get into this a little bit more, we're going to have to do more work to get these to fit. So, how do you feel so far? 4, 3, 2, 1, 0 me on solving by completing the square. Going okay? All right, so far so good. Now, this part, I might actually skip this because you guys are doing so good right now. I hate to add another piece that might mess you up. I think this will be a good place for us to just stop and say, you know what? Let's get this completing the square pattern down, and then tomorrow I'll show you why we use it. Okay? Let's do that. Nice, smooth transition back into school.